Hello everyone and welcome to this webinar. I am Pratik Potnis, subject matter expert in NX computer-aided manufacturing in iGetIt by Tata Technologies. So this is the webinar about using parameter sets in drilling operation in NX 2306 CAM application, where in this session we'll be discussing about defining geometry at first. Then we'll progress towards the discussion of defining tool and NC program, then defining the drilling operation and parameter sets, and at the last, tool path optimization. So in the defining geometry session, we'll be discussing at first the defining MCS, that is machining coordinate system. Then we'll define the machining part, and then we will define the blank for the machining operation. Then about defining tool and SC program. In this topic, we will discuss defining drilling tool parameters and then defining the NC program. Then defining drilling operation parameter sets. In this topic, at first, we will define the drilling operation parameters and then we will invoke the parameter sets and define them. Then at the last, the tool path optimization. We will see how the optimization of the tool path takes place for enhancing the machining efficiency. So this is the glance of the webinar, and having said this, let's dive deep to explore the topic. Parameter sets allow one operation to have multiple parameter things such as depths, feed rates, etc. So to begin with, open this part file called 9cyclesets.prt as I have opened here, and click on application tab and then click on manufacturing menu, where it will lead you to pop-up window called as machining enrollment. Here select the cam general option as the session configuration and select drill as the cam setup. If you do not find the drill template here, click on this option called as browse for a setup part and then navigate to the preset location where your drill template is there and select the required drill template as per the measurement unit. After selecting the drill as the cam setup, click OK. So now you are completely into the machining environment. In the part navigator, this is the geometric view where you can see the geometries, that is the MCS mill, and if you expand this, you can see one more option called as workpiece. At first, you need to make sure that the machining coordinate system, that is the MCS, is aligned with the WCS, that is the work coordinate system. To ensure this, double click on the icon, that is the MCS mill, and click on specify MCS option. And here in the reference, select WCS and let this drop down menu be set to as dynamic and click OK. So now you can see that the WCS and the MCS both have been aligned with each other. The safe clearance distance value, set this value to 3, as the safe clearance distance is nothing but the distance between the lower tip of the tool and the origin of the MCS before the machining starts. I have chosen this value as 3 just to ensure the safety of the workpiece just at the moment the machining starts. Click OK. So now you can again see that the MCS has been coincided with the WCS. So now you need to specify the part and the blank for the machining. To do the same, double click on the workpiece and click on specify part. Select the whole body, that is solid body of revolved 0. Click on OK. The part has been specified. Now to select the blank, first the blank is not visible here. So to make it visible, go to layer settings by pressing Ctrl L and activate the layer file, and now you can see the blank body, that is solid body of extracted body 1. So close here and again click on specify blank Now for select object option, right click, select from list and select the blank body, that is solid body of extracted body 1. Click OK. So now here you can see that both the part and the blank have been specified. Click OK. Now again press Ctrl L and deactivate the layer 5 because now we do not need the appearance of the blank. Click close. Now we will create the tool for the drilling operation. To create the tool, click on Create Tool option from the Insert group and in the Tool subtype, select the drilling tool. Name the drilling tool as per your desired name. Now I'm okay with this name, so I'm continuing by clicking OK. So here, give the tool dimensions as per your requirement. Like for suppose, here I want the diameter of 0.75 and with the point angle of 130. I'm pressing enter. It will automatically take the point length as per the calculations, and I want the length of the tool to be 3 units and the number of flutes to be 2. I will give the tool number 1 and adjust register number also as 1 and I will click OK. So now the tool has been created. To confirm the same, go to machining tool view and here you can see the drilling tool has been created. Now go to program order view and check whether there is a predefined program called parameter sets or no. If you cannot find any such program called as parameter sets, then create a program by clicking on create program command and here give the program location as NC program and name the program as parameter sets as shown. Then click OK and do not check this operator message status as I do not want here, but if you want it then you can check it as per your requirement and click OK. So now here you can see that a new program called as parameter sets has been created. So now you need to create the drilling operation. For the same, click on create operation command from the insert group and select the operation subtype as drilling and check whether the program is predefined to parameter sets, the tool as drilling tool, geometry as workpiece and method as drilling method. Name the operation as per your requirement, like I am naming this as drilling by parameter sets. Click OK. So here you can observe that there are 3 layers on the models on which there are holes which you need to drill by performing the drilling operation. Let's say the yellow, that is layer 1, the cyan blue, that is layer 2, and the last, the dark blue, that is layer 3. And to drill the holes on each layer, the parameters will be different, that is one parameter set for each layer. To do so, click on specify holes option, click on select. You can see here that this is for cycle parameter set 1. So here click on the option called as all holes on face and select the first face, that is face 1 of revolve 0, that is the yellow face. Click OK. So by doing this, you have selected all the holes on the face 1 to drill. This is about cycle parameter set 1. Now to go to parameter set 2, click on this option called as cycle parameter set 1 so that you will be directed to this window and here click on parameter set 2. Now here you can see that this is the window for selection of the holes for second layer, that is cycle parameter set 2. Again repeat the initial process that you did for the parameter set 1, that is click all holes on face. Now select the second layer that you want, that is the cyan blue layer, and click OK. In this way you have selected the holes to drill on the second layer, as you can see the highlight here on the second layer. Now again click on cycle parameter set 2, click on parameter set 3 and click all holes on face and select the last layer, that is the layer of dark blue color. Select this, click OK, and again select OK on this window. Now here you can see that all the holes of the 3 layers have been selected, but one problem is that the central point also has been selected as shown, that is the point number 25. So we need to omit it, otherwise it becomes the unnecessary operation for the tool, which is the loss of productivity. So to omit that point, click on omit option and select the point number 25 as shown here and click OK, and click again OK, and now you can see that the unnecessary point, it is central point, has been omitted. Click OK. So now expand the tool option and confirm that the right tool has been selected, it is a drilling tool, and whether the tool axis is correct or not. Yes, here the tool axis is pointed towards the plus ZM axis, which is correct. That is, the tool point, the cutting point should be perpendicular to the face, and here that is the case, so no worry about it. Now in the cycle type, click on the edit parameters option in the cycle type, and number of sets, here it has been listed as 3 by default, as we have specified 3 cycle parameters for the each phase, which are total in number of 3. So click OK, and observe that cycle parameters window has been opened up for the parameter set 1. Now recollect that this is for the parameter set 1, and for this parameter set 1, the face that we had selected is the front face, that is the yellow face, and for this give the depth, which is nothing but the model depth, as we require the model depth itself, and give the required feed rate. Here I'm okay with the feed rate of 10, so I'm okay with these cycle parameters for the parameter set 1. Click OK. Now you will be redirected for the cycle parameters of parameter set 2, as you can see in the status queue line below that parameter set 2 has been listed. So recollect again that for the parameter set 2, this cyan blue colored layer is the layer that we had selected. So for this, again the drill depth should be the model depth, and give the required feed rate. Here I'm okay with the 10, but you need to change here the retractor value to 3.6 as shown. Click OK. And this retractor value is nothing but it signifies the retraction value of the tool. The reason for the high retraction is that the step between the dark blue face and the yellow face is 3.5. So if you don't have a retraction rate of 3.6, the tool will run into the part. So therefore, as this gap between the yellow face and the last face is 3.5, so better I am giving the retraction value as 3.6. So click OK, and now define the same cycle parameters for parameter set 3. So similarly, give the depth value, and here I am keeping the depth value as the model depth, as I want here the tool to drill the hole up to the model depth itself, and give the required feed rate, that is I'm okay with the 10 value. And here again change the retraction value to 0.6. Click enter or click OK. So here the reason behind giving the retraction value of 0.6 is this face, that is the dark blue face, has screw heads that have a height of 0.5. So these are the screw heads which have been arranged here alternatively, whose height is 0.5 above the surface of the layer. So therefore better we give the retraction value of 0.6 here, otherwise the tool may retract with the part again. So click OK. So in this way we have defined the cycle parameters for all the cycle parameter sets. So now, having defined all the parameters that are required and all the options that we're being need to define. The only last option that we need to do is to click on the generate option under the actions bar, and the moment I click the generate, you can see that the toolpath has been generated, and this is how the toolpath is. So if I click on verify and replay 3D dynamic, and if I click on the play at the required animation speed, now you can observe that the drilling is happening so efficiently and as per the correct order on all the faces as you are seeing here. So this is all about using parameter sets in drilling operation, as here you can see that various parameters have been defined for the drilling under the same operation, that is the one operation called as drilling operation, thus reducing the total time required to complete this operation, as without this use of parameter sets there could be the need to define the each operation separately for each parameters. So this can be avoided and hence can gain in the overall productivity of the model. Click OK. Now, if you still want to optimize the toolpath, then in the drilling operation tab, go to specify holes and click on it. Then here in the point dialog box, click on optimize and click on the shortest path, as we want to reduce the length of the toolpath. That is nothing but the optimization of the toolpath, which ultimately yields in the higher machining efficiency. So therefore click on shortest path and click on optimize again. So now here you can see that before optimization the total length of the toolpath was 264.4169 units, and now after optimization it has been reduced to 161.5431 units. So click on accept and click on OK. And now again if you generate the operation, and now here you can see the difference in the toolpath, in the optimized toolpath I can say. So now again if you verify the operation at the desired speed, let's say 4, and if I click on play, now here you can see the difference in the toolpath and thus the increase in the machining efficiency. So this is all about the today's topic, in which we have discussed defining the drilling operation, then implementation of parameter sets and their importance, and at last the toolpath optimization technique. Thank you. And to explore more such fascinating concepts in NX, please log in to www.myigetit.com and explore the tremendous and fascinating knowledge, where not only you will gain the knowledge of NX, but this is the pool where you can get a tremendous knowledge of various CAD domains like PTC Creo, SolidWorks, Dassault Systems CATIA, and 3D Experience, Autodesk, and the domain-centric, that is the mechanical domain-centric knowledge base, that is GD&T, FEA, Automotive. So here, if you click on course catalog, here you can see the library of all the available courses that are there in iGetIt, and not only domain courses and the CAD courses, but we also have the PLM courses, that is Teamcenter, Windchill Creo, and to list them more. To get this tremendous knowledge, go to iGetIt, subscribe, purchase the iGetIt, and you will get the required industry-ready knowledge.